what we're going to do is I'm just going to make a rectangle here. And we'll just make a rectangle like this. We're going to talk about area right now. Covering all bases, aren't we? Practically covering half the geometry book just in this one lesson. So here's a rectangle. We want to find the area, and that's what we're doing here. We're finding the area of this. It's a rectangle. It's pretty easy. How do you remember area of a rectangle? Do you remember what the length times width. Good. Okay, we say length times width. Now what I'm going to do here is I'm going to do a little bit different than maybe you learned before. And I've taught for years it's length times width, but I'm leading up to something, okay? So you could also, excuse me, you could also call this the height and the base. So instead of length times width, I just changed the letters of it. So what could we call this instead of length times width? We could say the area. Yeah, or base times height. Okay, you with me on that? Now look at the height. There's something specific about the height. This is a rectangle, so what kind of angles do I have down here if this is a rectangle? It's a right angle, okay? And it's not the greatest box in the world, but you get the idea. All right, this height right here has to be, what do you think, to the base? Give me a good fancy geometry word. Not congruent. No, the height and the base don't have to be congruent to each other. That box right there. Give me a good fancy math word. Yeah, but it's only one angle though, so nothing's really adding up to it. What would you say? Starts with a P. Perpendicular. Okay, it's got to be perpendicular. Perpendicular means it makes a 90-degree angle. You with me on that? So two lines that make a 90-degree angle are called perpendicular. So the height always has to be perpendicular to the base. It always has to form a right angle. You with me on that? So when we talk length and width, it's kind of an assumption that we make. Oh, the length and the width, they got to be perpendicular to each other. So the base and the height have to be perpendicular. You with me? Okay. All right, let's look at this thing right here. Now we have a triangle. And you're used to this, aren't you? Aren't you used to using base and height when you talk about triangles? So if this is a base, and if I call that the height, this has to be what? 90 degrees, okay? The base and the height have to be what? Give me that word again. Got to be perpendicular, okay? So what is the area of a triangle? It's 1/2 the base times the height. Very good. Okay, that's the area of a triangle. I didn't do this, and I probably should have. Let me just do it real quick. Watch. Oops. Okay, here's a rectangle right here. And what if you did this? What if I went from here to here? Now, if I said this was the base and this was the height of that rectangle, I made a triangle out of it. Guess how much this triangle is out of the whole rectangle? It's half of it. You see that? That's how they get that formula for area of a triangle, because this triangle is half of that rectangle. Okay, if I call the rectangle base and height, you know, right here, then this would be half of the base times the height. You with me? Okay, so that's how they got that. Anybody ever show you that before? That's how they get 1/2 the base times the height. Okay? This was kind of easy because what kind of a triangle was this? We talked about this yesterday. It's a right triangle. Okay, that's pretty easy to see the base and the height. But what if you had a triangle that was not a right triangle, and you'd have to find the area of that triangle? Well, I'm glad you asked. Let's put one up here for that, like you care. All right, so here we have a triangle. This is obviously not a right triangle, but if I wanted to find the base and the height of this thing, watch this. If I call this the base, which one would be the height? Would that be the height right there? Would this be the height right here? Say it. Yeah. Well, through the middle, do you want to say middle? We'll go to the top, okay, and we'll make it what? Give me a word. Give me a geometry word. Yeah, well, come on. What's the word? We've said it several times already. Perpendicular, right. Okay, it's perpendicular. All right, so, yeah, straight, but look, that's a straight line, isn't it? That's a straight line. So saying straight, I know what you mean, straight down. I get it. But if we're going to be real picky about it, and I am sometimes kind of picky about it. Oh, that's even a worse box. There we go. I'm killing it. All right, so anyway, there we go. It's perpendicular. Now that would be the height. So you'd either have to know it or be able to figure it out and that kind of stuff. As we go on further, we might actually be given some stuff and you have to figure this out. And sometimes it can be pretty difficult to figure out what the height is. I think right now if they give you a problem with a triangle, they're going to keep it so that they give you the height and they give you the base. Now, this B right here is just kind of floating around, but what is the base? Well, it's the whole entire bottom of the triangle. It's not just from here to here. Does that make sense? Okay, so the base is this whole thing from there to there. You got it? All right, enough of that. You've seen that before, haven't you? Let's do another type of triangle. And that was an acute triangle. And so we call that the altitude sometimes, or the height. That was inside the triangle. Well, let's take this triangle right here. Let's make it a little bit bigger. Isn't that cool? I have all these triangles just sitting there. I put those there last year so I could have easy access. All right, so here we go. What if we did this? What if we wanted to find the height of this triangle? If I called that the base right there, now what's the height? Is that the height right there? Is that the height? Look, that's from the top down to the base, isn't it? So that must be the height, correct? Come on, what did we say? What did we say about the height and the base? They have to be what? They got to be perpendicular. Does that look perpendicular to you? No. And it's not just because it doesn't look like it. I don't have any right angle symbol there, do I? Okay, so I can't say that that's the height. So where in the world is the height going to be? Well, it's going to be from here. What do we say? Perpendicular to the base. Well, look, can I draw? Oops, that's a pretty bad spot. Let me get a better spot right there. Can I draw it perpendicular here? Is that perpendicular? Is that perpendicular? What if I keep going that way? It'll never be perpendicular. It gets worse and worse, doesn't it? So what am I going to have to do? Is that perpendicular? No. That's starting to look perpendicular, isn't it? But you're saying it doesn't even hit the base. But it's still perpendicular where the base would be, isn't it? So what I'm going to do is I'm just going to take this and kind of extend it out like that. You see it? So what is the height of this thing? This is the height. I should have done that in a different color. In fact, I think I can do that. Look at that. Pretty fancy, huh? Aren't you impressed? Boy, you guys are dead. All right. Humor me a little bit. Come on. All right, look, that's the height right there. Now, where's the base? Is the base all the way down to where the height is? No, because that part's not. This part right here really isn't even part of the triangle, is it? All right, what's part of the what's the triangle? What's the base of the triangle? It's just from here to here. So that, oops, squiggly. That's the base right there. You got it? That's the base, that's the height. So when you have an obtuse triangle, it gets a little bit weird, and you got to extend this base out right here, and you got to take the height from the top and drop it perpendicular. Remember, it's got to be perpendicular to the base. That's the key. If you remember anything from today, remember that, okay? That the base has to be perpendicular, or the height has to be perpendicular to the base. You got it? All right. All right, that's cool. Let's pause that. All right, now we got a circle. Now we're still talking area, but we're also going to talk about something else. Do you remember off the top of your head what the area of a circle is? Pi r squared. That's it. Pi r squared. Let's write that down. That's supposed to be an equal sign right there. Yeah, well, you got 2's and pi's and r's in both of these things we're going to talk about, and it's hard to keep track of which one's which. But if you think about it, area. Area is always measured in what? Like if I found the area of this room, or if I was going to carpet this room, what would I do? I'd go to Lowe's and I'd say, okay, I want some carpet. And they're going to say, okay, what's the area of your room? And I'll say it's 100 what? Square feet. You got it. Okay, square feet. So feet squared. Look what area has in it. It's got a squared in it, doesn't it? All right. So area is always with the squared. The circumference is the other one. Do you remember what the circumference is? It's not squared. It's 2. No, it's not cubed. It's 2 pi r. Look, they both have a pi, they both have a r, and they both have a 2 in it, right? But this 2 is a squared. So area is always squared, because when you buy something in area, right, carpet or something like that, it's always square feet. Circumference is just a distance around, right? So you're just measuring a straight distance. So it's just the radius. Does it make any sense? Okay, so circumference is what? It's the distance around this whole circle right there. That's the circumference. It's 2 pi r. Of course, the radius would be from here to here. Now, if I was teaching this from scratch, I would put so much more stuff in here, but you've already learned this. I'm just trying to get it to recall a little bit for you, okay? So that right there would be the radius, okay, from the center. That's the center of the circle, and this is a point on the circle. That would be the radius. Well, what about this line right here? What would that be? Just this line from here to here. It's a radius too, right? It's the same thing. All right. So what if this radius right here was 5? Then what's this radius? It's also 5. Every single radius of that particular circle right there is always going to be the same, isn't it? Because it's the same distance from the center to any point on that circle. Some people look at this and they just can't think. They'll say, okay, this is 5. What in the world is this? How do I find this? Well, it's another radius, right? The radii, right, are the same. Make sense? Radii, plural, right? You heard that word before, haven't you? Radii. Boom, boom. That's kind of a cool looking word, isn't it? The 2 eyes. Okay. All right. So that's pretty easy. So area, I'm not going to do any examples or anything. I mean, you can just plug stuff in. You know how to do this stuff. You know what pi is, right? What's pi? 3.14. Right. Is it just stop at 1.4? No, it just keeps on going. That's all I remember. I probably could remember more, but there's really no reason to go any further than that. I had a kid years ago. He memorized it to like over 100 decimal places. And it's a waste of time, to tell you the truth. I mean, I guess it's kind of cool. I guess it's kind of interesting to be able to just say that, but it's useless, to tell you the truth, in all practical sense. All right, enough of that. Let's do a little bit more with circles here. Let's pause this. All right, so here we got another circle. What we're going to do now is we're going to talk about a portion of the circle. We talked about the area. We're talking about the area of the whole entire circle. When we talk about the circumference, we're talking about a point and going around the whole entire circle. You with me on that, right? What we're going to do now is we're not going to go around the whole circle. We're just going to go around a portion of the circle. So let's put a radius in here, and let's put another radius in here, about right there. Okay, and I'm just going to make this up. Let's just make it easy, and let's just say that it's obviously more than 30 degrees. I'll tell you what, let's make it about 40 degrees. Okay, so let's say it's about 40 degrees right here. What I want to do is I want to find the area of just this chunk, this piece of the pie. Think of it like that. Pizza pie, if you want. Okay, I want to find just the area of that part right there. Not the whole entire circle. What if I did want to find the area of the whole entire circle? What would it be? It would be pi what? R squared. Let's make up a number. Let's just say it's 5 again, okay? So we could just put 3.14, put a 5 squared, that's 25, multiply them together. That's the area of the whole entire circle. But what if I just want to find the area of this little chunk, this little piece of the pie? It's 40 degrees out of the whole circle. How many degrees is the whole circle? 360. So how do I do out of 40? What math process do I go through? If I say 40 out of 360, divided by, good. 40 divided by 360. Did you see what I did? This is part of the circle. Make sense? It's 40 degrees out of the whole circle. So if I throw all this in my calculator, 40 over 360 times 3.14 times 5 squared, which is 25, throw it all in a calculator. I'm not even going to bother doing that, but there's your answer right there. Okay, and that's the area of just this chunk, this piece. They call this a sector, S-E-C-T-O-R. All right, the sector of the circle. Okay, that just means the piece of the pie. It's just a fancy math word for that. That's not too hard, is it? Okay, so whatever that angle is, we call this a central angle. Whatever that angle is right there, that's what. It's just that over 360. It would be the same exact thing for diameter or for circumference. Let's say I wanted to find out how far it is. We'll put a little mark here, a little mark here. And what if I wanted to find that distance right there? What if I wanted to find that length? It's not a straight line, is it? It's curved. It's going around a circle. So it's not the entire circumference of the circle, it's a portion of it. So if I wanted to find that length right there, I would say 40 out of 360, not pi r squared because I'm not finding the radius or the area. I'm finding just this distance right here. What would I put? 2 pi r. Good. So it's 2 pi what? 5 in this case. Yep. Chuck all that in your calculator, and then there's your answer. Make sense? All right. I think we're good. That pretty much, it comes real close to taking us to the end of the lesson. We'll probably finish it in 5 minutes tomorrow, and then we'll try to hit some of the questions that you might have had on it. So we have 5 more minutes of class. I am getting close. I like to get right to the edge. All right. That's enough, and hopefully we'll finish lesson 1 tomorrow.